So we are live. Hi everyone, welcome back to Geeks for Geeks practice. Today we'll be discussing this problem of the day that was for yesterday. Find the nth root of a number. So if I am audible to all of you and also my screen is perfectly visible, so you can consider giving a +1 in the chat and you can also like the video so that we can begin ahead with our session. Uh, just quickly uh, just quickly comment down +1 and give a like to the video so that we can begin ahead with this session today. Okay. I'll just wait for a couple of minutes for other people to join in and then we will move ahead talking about this problem. So this problem is named as find the nth root of m, that is you will be given a number m and you have to find its nth root, right? So this is what the problem is stating. We'll look ahead in the problem once more people have joined us so that nobody misses the problem statement, right? All of you can just quickly comment down below, like were you able to solve this problem yesterday, or if you were not able to solve this problem yesterday, quite quick if you can give me a brief overview of that, so that will be helpful. uh, I'll just wait for some time for other people to join in, and then after that immediately we'll begin. Just give a +1 in the chat and you can also consider liking the video. Okay, how many of you were able to solve this question? Find the nth root of m. How many people were able to solve this question? Just quickly comment down below. You can just consider commenting down below quite fast so that we can begin ahead with the session. Okay, right. So the problem name is find the nth root of m, and just to give you a brief detail about this problem, so this is an easy problem, and this is an easy problem. Basically it is definitely an easy problem because this is a pretty standard question, and it's the accuracy level for this question is something very close to 50%. Okay, apart from this, the number of submissions for this problem are 12,000. The number of points offered for this problem are 2. So you have been given two numbers n and m, and you have to find the nth root of m. Okay, this is the problem statement. Is the problem statement clear to everyone? You have to find, okay, you have to find the nth root of m. Is the problem statement clear to everyone? You have to find the nth root of m. Find the nth root of m. Okay, this is what you have to do. How should we approach this problem, right? So how should we approach this problem basically? So if you will see, so let's say if you were given m is equal to, let's say, 81, right, and n was 4. If n was 4 and m is equal to 81, so in that case what would happen is, in that case basically you will say, hi Anirudh. Okay, great. You can like the video if you haven't already. Okay, right. So the problem that we are discussing today is find the nth root of m. So all those people who have joined now, I'm just telling for them. And let's suppose that m is equal to 81 and n is equal to 4, right? So you have to find an integer. You have to find the nth root of m. Okay, so you have to find the fourth root of m, right? So what will be the fourth root? So that will be nothing but 3. Why? Because if what is the nth root, right? So nth root of a number is a real number, right? Let me write it. Nth root of a number is a real number that gives m when it is raised to the power, when it is raised to the integer n. Okay, this is what the nth root means. Basically what you have to do is, you have to find the nth root of a number, and nth root of a real number, let's say m. Nth root of a real number m is nothing but a number such that when you raise it to the power m, when you raise it to the integer m, then it gives you when you raise it to the integer n, right, so you get what? You get m, right? So this is what nth root of a number means. Basically you just have to check that what is the number, what is the particular number raising which raising to the power n, multiplying it n times gives me n. That is what nth root of a number means. Now what do I mean by that? So if I say that 3 to the power 4, so then what will I get? I will get 81, right? And what is 81? M is equal to what? M is equal to 81 and n is equal to 4, right? So the nth root of this value m, that is 81, is 3, right? Because you multiply this much number of times and you simply get the answer, right? This is what happens, right? Now let's take some more cases, right? Let's say if the number given to me is, let's say my m is equal to 4 and n is equal to 2, right? For this case what will it do? So you will have to find the second root of the number m. So what is the second root? So second root means square root, right? So you have to find the nth root of number 4, right? So if you take 2 into 2 gives me 4, right? So 2 to the power 2 raised to the power 2 will give me 4, where the value of m is 4 and n is 2, right? Let's take another case. If let's say I have m is equal to 27 and n is equal to 3, right? So for this case I can see that I multiply 3 times, right? So this means that 3 to the power 3 gives me a 27. So in this case you can see that my m is 27 and n is equal to 3. So this is my, this particular number is my nth root, right? Is this much part clear to everyone? Just quickly give a +1 in the chat and like the video if this much part is clear to everyone. If this much part is clear to everyone, then please quickly give a +1 in the chat and please like the video. Is this much part clear to everyone? Okay, let's begin. Let's move further. So let's look at some of the examples that are given. So if let's say n is equal to 2 and m is equal to 9, right? Let's take this case as well. So let's say that I take this case as well with me. So if n is equal to 2, I have to find the second root of m is equal to 9, right? So in this case you can see 3 into 3 gives me 3 to the power 2, which is nothing but 9, right? So I get m, the nth root of the number m is nothing but 3, right? Because you multiply 3 times and you get this number, right? So hi Samyank, yeah, all of you who have just joined now, so you can consider giving a +1 in the chat and you can like the video if you haven't already. Okay, right? So moving ahead, let's see the what is the next test case. So if let's say I have n is equal to 3 and m is equal to 9, okay? So if I have n is equal to 3 and m is equal to 9, so you can see that for this case like n value has changed, n is equal to 3 and m is equal to 9, right? So for this number you know that there is no integer number such that it can be made such that there is no number x, there is no number with you x such that you raise it to the power n and you get this value m, right? Because there is no number like that, right? So that is why in such cases you will simply print -1, right? This is what there is no third root of 9, okay? Third root of 9 is not an integer, right? Alok Ranjan, okay, everyone is clear with this? Just if someone has joined just now, so they can please write a +1 in the chat and they can like the video if they haven't already. Okay, now let's say there can be other cases as well, right? Other cases can be, let's say I give you m is equal to 4 and I give you n is equal to 3. So for this case there is no integer x such that you raise it to the power n and you get 4, right? There is no integer x, there is no integer value x such that you raise it to the power 3 and you get 4, right? So that is why note that x has to be an integer, right? X has to be an integer, right? So that is why in such cases you will simply print -1. Is the question clear to everyone? Is the question clear to everyone? Just quickly write it down. Is the question clear to everyone? Is the question clear to everyone? Just quickly write that down in the chat. Is the question clear to everyone? Is the question part clear to everyone, so that we can move ahead with the solution part? Is the question part clear to everyone? Is the question part clear to everyone? Let's say let's take this example, that is m is equal to 81, right? So if my m is equal to 81 and let's say my n is equal to 4. So in this case, this is the situation, and in this case what I'll be doing is, yeah, right, it is clear. Okay, great. So if m is equal to 81 and n is equal to 4, so you have to find an integer x such that x to the power n is equal to m, right? And x has to be an integer, so x to the power 4 is equal to 81. You have to find such an integer, right? So you are sure that the nth root, first of all, nth root will lie between 1 to 81, right? Everyone will be clear with that. The nth root will lie between 1 to 81, right? It cannot lie outside 81, and the minimum value that it can have is 1, right? Everyone will agree on that, right? After this what can we do, right? So this much part is clear to everyone, right? After this, what can we do next? So next up, what we can do is, if you are trying to brute force, so what you can do is, you can run a brute force for all the numbers from 1 to n, and you can do an I plus plus 1 to m, okay, 1 to m, and you can do an I plus plus, and you can try to find the power of ith number, right? Power of ith number raised to the ith number raised to the power n. And in this case, what will happen? In this case you will simply get the value, if you get the value equal to m, right? If you get the value power of I comma n is equal to m, then you will simply return your I, right? That particular integer will be your final answer, right? Everyone will agree on that, right? So if you do it in a brute force manner, so the time complexity will be a lot. What will the time complexity? Since you are generating all the for all the numbers, so this will be order of m, right? And this power function, it is running order of n time, right? For each it is running from 1 to n, right? So for multiplying the number I n times, right? So that is why it will be order of n. Since this is a nested loop, so that is why the time complexity for the brute force will be n cross m, right? So this is very costly for us, right? So if we do it like that, so the time complexity that comes out for us is nothing but order of n cross m, right? Brute force. For brute force, we get this. Can we do it in a better manner? Can someone suggest me how should we do this? Can anyone else suggest me how should we do this? Can anyone else suggest us, like, what should we do? Anyone else can suggest us what shall we do? I said that if the power of I raised to the power n is equal to m, for this the function takes order of n time, right? So if you will apply a brute force approach, so you will take total order of n cross m times. So this is a brute force, right? Why it will lie between 1 to 81? Because you have to find an integer x. Right? Why? Because you have to find an integer x. Such that when you raise it to the power n, you get m, okay? And you have to get m, right? The value that you have to get is m. If the value will be greater than m, then in that case you will be exceeding, right? You will, if this value x, if you keep x, that is x is greater than m, so in that case if you raise it to the some power, that is integer power, so in that case it will exceed m, right? And if you take it negative, so what is the need to take it negative, right? Because x can be an integer, x can be a positive integer between 1 to m, and you can surely get your answer, right? That is why we are doing it. Because if you will take x greater than m, if x is greater than m, then in that case you raise it to some integer n that is greater than 1. So in that case, instead of going from 1 to 81 linearly, we can use binary search. Yeah, right. So I can see some people have joined. So if someone is there who hasn't liked the video, so they can consider liking the video as well, okay? Let's discuss this problem. Let's discuss this now. What we can do is find the nth root using binary search, right? Find the nth root of m using binary search, right? How can we do this? I will discuss this. Binary search. So how do we do this? This is the task that lies ahead. So what we can do is, you can see one thing. observe just one thing, x to the power n is equal to m. That is the case for us, right? So if my m is equal to 81 and my n is equal to 4, so in that case I can say x to the power 4 is equal to 81. I have to choose such a number x such that when I raise to the power 4, so I should be getting this number, right? So what will happen, right? So if I have choose, let's say I take 1 to 81, right? I know for sure that everything lies between 1 to 81. The answer lies between 1 to 81. Now why binary search? The first thing is, why binary search? Can someone in the chat tell me why we can apply binary search, or why we are applying the binary search? Why? First let's answer this. Why binary search? Because we apply binary search when the search space is sorted, right? Is sorted either in ascending order or in descending order, right? So you can see that all the numbers from 1 to 81, since you are having this range, so this range is in itself sorted, right? 1 to 81, you move one by one, all the elements from 1 to 81 you move one by one, and all the elements are sorted in ascending order, right? That is why you can apply a binary search. Now how will you apply a binary search? That is the question that lies ahead. Yeah, range is sorted, right? Time complexity is log n. Can you just think of little bit more, like what is the overall time complexity, right? After this what I'll do is I will choose a mid, right? First of all, I'll start the start index, I'll be marking as 1, and the end index I'll be marking as 81, right? After this I will choose start plus end, and it will get divided by 2, right? So this will be my mid. So what will be the value of mid? Value of mid initially will be 82 by 2, that is 41. So if I get 41, right, if I multiply 41 4 times, 41 to the power 4, is it greater? 41 to the power 4 is greater than 81, right? Everyone will agree on this, right? Everyone will agree on this. 41 to the power 4 is greater than 81, right? Everyone will agree on this, right? So that is why I cannot make 41 as my 41 is not my number, right? 41 to the power 4 gives me greater than 81, right? So that means that 41 is not my nth root, right? Yeah, right. Okay, so that is why what will I do? I know for sure that if 41 to the power 4 is greater than 81, so any number between from 41 till 81, it will also be greater, its value raised to the power 4, its value raised to the power n, any number between 41 to 81, its value raised to the power n will also be greater than 81, right? So that is why I'll be checking towards the left of mid, right? So now my the new range will change, and my new range will be from start, I can say start to mid minus 1. Everyone agrees on this? Does everyone agree on this? Everyone is clear with this much part? Everyone is clear with this much part? Right. So that is why I need to change my search space, and now it will change from 1 to 40, right? Everyone will agree on this, right? And after this, what will I do? What will I do further? So let's see. Now my start is nothing but 1, and my end is 40, right? Because if 41 to the power 4 gives me a greater value than 81, so that means all the numbers which are towards the right of 41, they will also give me this, right? So that is why we are doing it. So my start now is 1, and my end is now 40. So what will be my value of my mid? So my mid comes out to be nothing but 41. So 41 divided by 2 gives me a 20, right? Let's say it gives me a 20. So if I'm getting a 20, so in this case what will I do? In this case what will I do? If I'm getting this, so I can see, let's try and see 20 to the power 4, what does it give me? So this is 20 into 20 into 20 into 20, and you can see that it will be greater than 81, right? It will be greater than 81. So again you can observe one thing, again you will observe. So in this what you did was start was pointing to itself only, but your end now changed, and was changed to mid minus 1, right? So in this way you can see that it is still greater than 41, right? So if 20 is greater than 20 to the power 4 is greater than 81, so that means all the numbers from 21 to 81, from 21 to 40, right? From 21 to 40, that is our search space. From 21 to 40 will raise to the power 4 will also be greater than 81, right? So that is why I will change my search space from 1 to 19, right? So that is why I'll mark my end as mid minus 1, right? My start will remain the same, but my end will change. My end changes to mid minus 1, right? Everyone agrees on this? Just quickly tell me. Okay, perfect. Perfect. So if someone new has joined, so they can just consider giving a +1 in the chat, and they can like the video if they haven't already. Okay, right. So this is what I will do. Now let us see what we will do. So I'll mark my end as mid minus 1, and my mid was what? My mid was 20. So now my this will be 19, right? So let's update. Let's update. Start is nothing but 1 again, 1 as it was initially, and now my end is what? End is 19. Let's see what we will get next, right? What I will get next, let us see. So if I will see further, so my mid now will be nothing but 10. Let's see, 10 to the power 4, so that means this 10,000, right? And 10,000 is greater than 81. Everyone will agree on that. So that means that all the number from 11 to 19 raised to the power 4, any number from 11 to 19 also, if 10 to the power 4 is greater than 81, so that means that all the numbers from 11, that is towards the right of 10 up till my current ending range, so all the numbers from 11 to 19 will also be greater than 81, right? Raised to the power n will be greater than 81, well, right, will be greater than 81, right? So that is why I need to change my search space. So that means the element will the x that I am searching for, it will lie towards the left. It will lie towards the left. Okay, so that is why x will lie towards the left of mid. X lies towards the left of mid, right? Left of mid, right? This is what you will do. Now let's quickly see what you will do, right? So that means my end will change to mid minus 1, right? Because I've checked for current, so my end now changes to mid minus 1 again, right? So what will it be equal to? It will be equal to nothing but 9, right? After this let us quickly calculate the mid. Let us quickly calculate the mid now again. So what will happen? Now my mid is what? My mid is 5, right? My mid is 5, and since my mid is 5, so that simply means now I get the mid 5. Now 5 into 5 into 5 into 5, that gives me 625. 625 is greater than 81, right? So that means all the numbers towards the right of mid, that is all the numbers from mid plus 1 up till the end raised to the power 4 will also be greater than 81, right? So all the numbers from, if 5 to the power 4 is greater than 81, so that means that 6, 7, 8 or 9, any number, you take any number in this range, any number raised to the power 4 will be greater than 81, right? So that means that my number will be lying from my start range to mid minus 1 range, right? Everyone will agree on this, because it cannot lie towards the right of mid, it will lie towards the left of mid, right? Because if you see, so if you take elements towards the right, so that gives me answer greater than n, right? After this, what will I do? I'll update my search space. So currently my mid was 5. Now my mid will be what? Now my end will be 4, that is mid minus 1. So mid was 5, so that is why end will be mid minus 1, that is 4, right? After this I will check what is my mid. So my mid that I get 1 plus 4 divided by 2. What do I get? What do I get here? I get 5 by 2, right? That is nothing but 2, right? So that means that if you take this number, so 2 to the power 4 gives me what? 2 to the power 4 gives me what? 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16, right? It gives me 16. 16 is lesser than 81, right? 16 is lesser than 81. So now all the numbers, that is all the numbers towards the left of my mid will also be lesser than 81. Raised to the power 4 will also be lesser than 81, right? So now I can surely say that my number will now lie, my number that I am searching for, that my x, that is an integer that I am searching for, it will lie from what? It will lie from what range? 3 to 4. Everyone will agree on this, because I will update my start to mid plus 1, that is 3, and my end is already pointing to 4, right? After this, what will I get? So let's quickly check what will I get. So now my mid will be what? My mid will be 3 plus 4 divided by 2, so this simply gives me a 3. So now my mid is 3. Let me check. 3 to the power 4, it gives me 81, right? 3 to the power 4 gives me 81, and it is equal to 81. So in that case, I will simply return my mid. Everyone is clear with this much part? Just quickly tell me. Everyone is clear with this much part? Only then I can consider moving ahead, right? Everyone is clear with this much part, right? Everyone is clear with this much part for this example? Everyone is clear with this? I want the answers from everyone. Like, everyone is clear with this, right? Because now you get a mid. The mid value is 3, and 3 to the power 4 gives me 81. That is why I'll return the mid. This is my, so my x value for this case is 3. That is what I want to return. This is the nth root of the number m. Everyone is clear with this? Just quickly tell me in the chat. Yeah, right. Okay, so let me show you the code part for this. First of all, let me show you the code part for this problem, how we are solving it. So what I'll be doing is, I'll be having start will point to 1 and my end will point to m, right? Since I'm applying a binary search, so my start should be less equal to end. My mid will be calculated, that is start plus n divided by 2. If I say that power of mid comma n is equal to m, right? So if mid raised to the power 4, if mid raised to the power 4, if it is equal to m, if mid raised to the power n, if it is equal to m, so in that case I will say that the current mid, I will say that mid is the nth root, right? Mid is the nth root, right? After this, I will check in the else if my mid to the power 4, if it is lesser than m, right? If my mid to the power n, if it is lesser than m, so in that case I will say that my start will be I will change my mid. Since my mid is less, so all the elements towards the left of mid will also be lesser, right? So that is why I'll change my search space from mid plus 1 to n. And same way, if my mid to the power n is greater than m, so in that case I'll change my search space from mid to mid minus 1, because all the elements towards the right of mid will give me what? All the elements towards the right of mid will give me basically will give me a greater answer, right? So that is why I'll change my search space from low to mid minus 1. And you can see that this binary search will get violated as well, right? This binary search, such binary searches will when will I return a minus 1? That is the case. When do I return a minus 1? I will return a minus 1 when my number that I have, when I do not get the nth root, right? When I do not get an integer value x such that I raise it to the power n and I get m. So in that case I'll be doing, so this when this binary search terminates such that my start is greater than n, right? Or my end is lesser than start. So in that case my binary search will terminate, and in that case if I come out of this loop, so I'll simply return minus 1. Otherwise, if I have some nth root if nth root exists for the number m, so in that case I will return mid. That will be my nth root. Everyone agrees on this? Everyone agrees on this? If everyone agrees on this and this part is clear to everyone, please give a +1 in the chat and please like the video. Please give a +1 in the chat and please like the video if this much part is clear. Up till what value of integer does this power function will give correct answer? What you can do is, if you want, you cannot, you don't necessarily need to use this power function. What you can do is, you can do two things. Either you can do fast exponentiation. You can also use fast exponentiation, right? You can do fast exponentiation. So if you are doing using that, so in that case the function, the answer, the power c plus plus, right? So if in that case fast exponentiation will give me an answer in log n, right? Fast exponentiation does the power part in log n time, right? Log n time. But if I am doing linearly, if I am iterating, if I'm using the power function, so in that case what will happen, in that case if I'm doing power of mid comma n, so in that case the time complexity will be order of n, right? So you can see that this will be better, right? Which is better? Fast exponentiation can be better. If you don't know, so you can search when should we start list and start list. Are these both different cases of binary search? It depends. Why does it depend? So here what is happening is I am changing my start to mid plus 1 and end to mid minus 1, right? So that is why I'm taking start is less equal to end. I I if I was changing my start to mid or end to mid, so in that case, if instead of doing this, if I was marking my start as mid and my end as mid, so if I was doing things like that, then in that case this equal to sign would have been removed, right? So if I will not do this, so in that case if the start is equal to end, so in that case I will not be calculating my mid, right? If the mid is equal to start, or if the mid is equal to end, and that is my answer, so in that case I'll be returning -1. That is why the way I am doing it, I am changing it very in a pretty standard manner, because if the mid raised to the power n is, if it is less than m, so all the values towards the left of mid will also be lesser, right? So that is why I'm changing my start to mid plus 1, and if my mid to the power n is greater than m, so in that case I will be changing my answer. So that means that I'll find my answer from start to mid -1. That is why I'm changing it in this way, right? So everyone is clear with this? If everyone is clear with this, so please like the video. Please like the video if you haven't already, and please give a +1 in the chat if everything is clear. Please quickly give a +1 in the chat if everything is clear to you. If everything is clear, so please consider giving a +1 in the chat. Please give a +1 in the chat, and simply if the binary search terminates, so in that case you will return -1. Now let's see, right? What will be the time complexity for my code? The code in which in this way that I have written. Okay, so since binary search takes what time? Binary search. So binary search is happening for what? Yeah, right. Yes, great work. Okay, thanks, Samyank. Okay, so right. So binary search will take order of log m time, right? Since I'm searching in this space 1 to m, and I'm dividing my search space to half every time, so this will take order of log n time. And also one more thing that I'm doing is fast exponentiation, right? If I am doing fast exponentiation for calculating mid to the power of let's say m, right? If I want to calculate power of mid to m, right? If I'm doing fast exponentiation, right, and I'm calculating it using this, so in that case if I am calculating the power of mid, if I am doing mid to the power 4, let me write it much more clear. Okay, we will make a video on fast exponentiation. If I'm doing fast exponentiation, so in that case what will happen is my time complexity for fast exponentiation for mid raised to the power n will be log n, right? So that is why my overall time complexity will be n log n into log m if I am doing it using fast exponentiation. And if I am doing it using simple power function, inbuilt power function, that is or I am using a loop, so in that case it will be n into log m. Okay, so is this clear to everyone? Is this much code and everything clear to everyone? Just please give me a +1 if it is clear for the one last time, and please like the video if you haven't already, right? So this was the way that I tried to explain this problem, right? So if anyone has any doubt, you can mention that in the comments. Otherwise you can write crystal clear in the chat. Okay, everyone is clear with this much part? Great. Okay, I'll be just waiting for 30 seconds more. If anyone has got any doubt, so they can mention that in the comments. Otherwise we'll be ending this session. Okay, so